All right. Good evening once again, guys. So, uh, we are at the bank of our last session. However, yesterday we just started some kind of topic named as to be air conditioning concepts. So, in air conditioning concepts, we learned about a lot of systems, such as to be VAV systems and similarly TFA systems, isn't it? And down the line we learned, yeah, these are the three systems that we've been learned in the last session. Then on the continuation of this air conditioning concepts, the next one is named as RCT. So basically RCT refers to radiant cooling technology. What is it? Radiant cooling technology. So symbolically here, you know, probably inside our buildings mostly you will be having a lot of indoor units such as the air handling units, isn't it? Preferentially the concept of this radiant cooling technology is to like a green building concept. So green building which refers to lesser energy consumption, isn't it? That is the same idea here also we will be adopting. So in this RCT, you know, once again guys, normally, in other air conditioning concepts, such as to be the HRW, or even if you consider any kind of air conditioning process, it should be implemented after the construction of building itself. But whereas in the case of this RCT, which is the radiant cooling technology, an initial decision making is very important. Why? Because here you know the entire masonry elements of the building is covered with some kind of pipelines, and these pipelines are terminated right onto a conventional chiller. So once again guys, in this RCT you obviously doesn't have any kind of indoor units, so that is the point right here. You can see the IDUs are avoided. Okay, now the IDUs are avoided right inside here itself. Then comparatively, if there is no IDU, probably the energy consumption should be much lower, isn't it? But however, you will be having a uh, conventional chiller for that assembly itself. Okay, now then if you need some kind of additional systems such as TFA, you can implement that along with the RCT itself. So look at this picture right here itself, guys. You can see initially they are laying pipelines on each and every masonry elements of the building, especially the floors, walls, and similarly the columns, beams, in entire things they are covering up with these kind of pipelines, and later it should be terminated to the chiller itself. Okay, now so later it should be terminated to the chiller like this. Yeah, you can see this now. So should be connected to a basic chiller plant. So from this chiller plant, across this pipe system, cold water should be flowing right through those pipeline itself, and it should be again reverted back into those respective chiller itself. Once again, guys, here the basic idea is the absence of IDU. Okay, then you know the remaining working. So once the air or the heat transfer occurs, these chilled water pipeline which implemented right onto the masonry elements, gradually as of the heat exchange takes place, the incoming heat will become cold. Why? Because a small heat exchange will takes place between those pipe and the atmospheric air, isn't it? So this is how your rooms getting cooled downs. Actually, in this RCT, it only have a single advantage. Why? Because I told you here there won't be any kind of IDUs. So respectively, the energy consumption of those AHUs should be absent. That's it. Or should be comparatively no, it's wouldn't be there, isn't it? The only cost that should be consuming you, it's the chiller cost, which means the energy consumption for the chiller. That's it. So here you can see. The chiller water pipes are running through each and every masonry element in the building, such as walls, columns, beams. So as if the elements gets cooled down, gradually room air temperature goes down. So this is the concept. So the first advantage I told you, no IDU energy consumption. Once again, the supply line and return line, it should be same itself, guys. Which we've been studied now. That's it. And you can see these are, only one advantage. Then you will be having a lot of disadvantages. So initially, a great amount of decision making and planning is included. Why? Because I told you it's an worst case scenarios. Actually, there is no use why implementing this kind of RCT. Why? Because initial cooling takes longer than other technologies, and similarly, we can't provide precise cooling, and we can't control the zone loads, and even can't control the temperature, humidity, oxygen level, and we can't control the order right inside the room, isn't it? So these all are a drawbacks of this RCT itself. Okay, now. So sometimes, I told you, as if the atmospheric air consists of this moisture comparatively contacted with these walls and this structure, what will happens eventually? It will drip down. That means condensation will takes place. So due to this condensation, water droplets should be formed on the surface of the entire arrangement. So that should be a small risk to us, isn't it? To the client. That's what I'm saying. So in order to overcome that scenario, which means to control the temperature and humidity, you can additionally add an TFA, which means introducing a TFA can avoid the dew formation on the masonry surface. At the same time, it can regulate the humidity level inside those spaces itself. Once again, guys, in order to do this stuff, actually, you need to initially turn on the TFA. And after turning on the TFA, once the humidity and temperature is set down, now you can turn on the chiller by providing the water across the chilled water pipeline itself. Okay, so this is the concept of RCT, or radiant cooling technology itself. Is it clear? Okay, now, next of all, it is a basic concept called as to be air stratification. Okay, so here the air stratification is based upon the density of air. We studied that cold air always have high density, and hot air obviously will have low densities. So the working, especially in the cases of this theaters, even this double ceiling height areas, in those uh, in those spaces, generally they will go with some kind of jet or nozzle diffuser, or even eyeball diffusers. So these kind of eyeball diffusers are placed on a certain height from the floor level itself, isn't it? Like I told you, for double height ceiling levels, they will be implementing these kind of eyeball diffusers. However, if the height is too high, that's not a problem. Why? Because from those diffusers, you will be getting the cold air. Now, we studied that cold air will have always high density. So eventually, it will come to the bottom side of that area itself. And that's how the entire area is getting cooled down. At the same time, the hot air will always prefer to go upside. So this is meant to be the air stratification itself. Okay, now that's it. Next of all, it's about something called as to the district cooling. So these kind of systems are implemented or deployed around various side of our globe itself, especially in Burj Khalifa and the nearby areas. Here, in order to reduce the space consumption on that building, specifically providing some kind of chillers, instead of that, for that entire area, not saying a single building, the nearby restaurants, hotels, commercial buildings, museums, financial institutions. So for that entire area, they will provide a common chiller plant. And these chiller plants should be implemented in a certain distance of radius around that area itself. Okay. So from here, which means from this chiller plant, the pipelines will be implemented in a buried method itself. So that's why I told you, especially in the case of secondary piping, you need to know about the two basic schedule numbers, schedule number 40 and schedule number 80. So normally for buried pipelines, we will be using schedule 80 above pipes, especially it's having high wall thicknesses. Why? Because it should be buried. So obviously it need to overcome the stress from the respective soil and other kind of aspects itself. So that's why we will be using this kind of uh, schedule 80 above pipeline structures. Then once again, so from this big common chiller plant, the chiller pipelines, especially the supply pipelines and the return pipelines, should be buried below the earth, and it should be carried across your each and every buildings right on the area. So whatever the buildings that depends upon the chiller plant, from the chiller plant, they will be transferred these kind of pipelines across the building itself. So once these water enter the building, you will be having a small arrangement called as to be ETS. So ETS means energy transfer system. It's like a plate heat exchanger or some kind of heat exchanger. So initially it will cool down the temperature. As if the water travel more distance, eventually it may can lose its temperature, isn't it? So in order to brought back to the certain levels, we will be using again a heat exchangers on the base of that building itself. That's an ETS, energy transfer system or energy transfer station. And from those energy transfer station, again the chilled water is supplied across the entire AHU right onto the building itself. Now, when it comes to the return path, again, you will be having an ETS to collect the entire water, which means the cool down water should be collected right there itself. And cool down, not cool down. That means the return water. Okay, what I'm saying is the return water from those AHU should be collected onto the ETS, and a small heat exchange will happen, which means it's a comparatively colder water. So if there is any stations which having, that means the ETS will make a small heat exchange to absorb the energy from the return water itself. And again, the return water should be flown across to the common chiller plant. So this is the concept behind district cooling. So the advantages of the district cooling is for each individual buildings, we don't need to prefer a chiller plant. Instead of that, for that entire area, I can deploy a common chiller plant. So this is the concept of district cooling. So actually in Burj Khalifa, they done like that way itself, which means for the Burj Khalifa and the nearby restaurants and hotels, they provided like this. And I think the tonnage is around like more than 60,000 ton. And it is sorry, the HVAC brand that is they are using for the district cooling is done by Voltas itself. I hope so. Yeah, Voltas is doing their district cooling. Okay, now that's it. Later, it's about the BMS. So you've been heard about the term called as to be BMS. So BMS stands for Building Management System. So this building management system is something like a, what we can say. Yeah, they are the, what we can, yeah, pacemakers of the building. Why? Because the entire connections, which means to be the fire detection alarm system and the FACP panels, and similarly the chiller plant status, cooling tower status, AHU fan speed controlling. So this each and everything is controlled by the BMS guys itself. Okay. So they are responsible for the entire movement of the building. So from the CCTV, which means from monitoring to controlling, they will handle these works. Okay. I hope it's clear. Is there any doubts, guys? No, isn't it? I hope you got the point. And after that, now let's discuss about, so this is all about the air conditioning concepts. Okay, now, if you have any doubts, just let me know, guys. Okay. Is it clear now? So can we
Yes,
jump
sir.
on? Yeah, fine. So can we jump on to a next topic? Next one should be installation and field practices. So it's a very basic thing, which means some kind of precautions that you need to consider while going to a site or something. So first one, the piping side knowledge. So generally, beyond this theory, we must need to know about some kind of base stuff, such as to be we will be using soft drawn pipes and hard drawn pipes for the primary refrigerants, isn't it? Soft drawn should be used for below 4 ton application, and Hard-on pipes are used for above 5 ton application, isn't it? So, however, these are you joined by brazing method. At the same time, you can use welding also. But as in the case of secondary refrigerants, I told you we will be using MS pipes, which is mild steel pipes, isn't it? Then in the case of ducting side, always you need to deploy a flexible canvas connection to connect the machine to the duct itself, which means from the mouth of a machine, if you are subjecting a duct work, you must need to implement a flexible canvas connection. Then only we can prevent the vibration transmitted from the duct system itself. And next of all, it's about the connection pieces. I hope. Just 1 second. So these are the angle joints. Okay, now. So angle joints in ducts. We can see not like this. I hope. Yeah, it's sheet. Yeah, here you can see it's some kind of connection pieces that we are actually using. This is TDC, transverse duct connector. Yeah, you can see right here itself now. So I'm going to zoom it right itself. So this is meant to be the cleat joints. Okay, now, and this is the transverse joint which is used on the corners, and the cleat joints are used on the for holding these two ductworks. That means normally ducts should be implemented, sorry, the ducts are fabricated for not like a 10 feet distance, 5 feet distance. Normally it comes along like a 1 meter distance something. So you need to connect, it has to be a piece, which means the first main piece 1 meter, the next main piece it should be the second piece. So you need to connect these rectangular ducts respectively. So at this time, in order to connect these one, you need some kind of connection pieces, and that's why we will be calling it as to be a transverse joint. And you can see the lot of stuffs are there actually. Yeah, you can see this is the 4 bolt frames. It's an connection wheel. You can see it in your YouTube also, whatever. And importantly, you need to must know about the transverse joint and the cleat joints, and this is the cleat joints that we will be using to connect the two sides of a duct itself, which means to chain up the entire ducts, we will be using the cleat joints. Okay, next of all, it's about, you can see, expandable screws are used to mount the ducts, which means the threaded drops. That's it. Later, always we need to place a gaskets were on the joining of those duct itself. That means if you are connecting two ducts on the opening side of the duct, which means I'm not saying on the open side, onto the connection piece, I told you now, normally you will be having flange ends. Flange means you have some kind of 4 holes will be provided on the ductwork, and it should be connected with the help of nut and bolts. At the same time, a gasket should be provided. It's like a double tape itself. Okay. So this tape should be properly uh, sticked around the ductwork itself, and you can connect the other duct onto that gasket in itself. So that's how the leakage is prevented. Then, while using insulation, a proper kind of adhesive should be opted. Otherwise, eventually the adhesive lost its power and the insulation may can fall off. Then never run the air handling unit unless the AHU room is truly cleaned and the air filters are mounted. AHUs should be always run with the air filters mounted. Otherwise, what will happen? The dust particles should be formed up right onto the cooling coils, and eventually it can block the eventually it can uh, create some issue with the contact factor, the amount of air getting contacted with the cooling coil. All right. Later, it's about the outdoor unit. So while mounting an outdoor unit, a proper airflow should be maintained, and you don't need to provide your ODU near to any heat emitting equipment. At the same time, a safety railing or catwalk should be provided when the machines are mounted above the floor level. That means normally on the terrace sites, if you are implementing this kind of outdoor units or this ODUs, you must need to use some kind of safety railing for the maintenance guys. Okay, that's it. Later, it's about the pressure testing in the copper piping. Normally, the pressure testing is run in order to know whether there is leaks are there. Generally, we will be using nitrogen. Okay, now. So after installation and erection of the entire pipe circuit, which is the primary piping, that means the copper piping. Okay, now. And at the same time, a soap film will be coated all over the pipes, especially the joints like the elbows, T-junctions, ref nut joints, four-way header joints. Once the nitrogen is charged according to the required pressure, if there is any leaks happen, eventually a soap foam will appear. Or otherwise, you can use an halogen or electronic detectors. So these detectors can sense the leakage of those nitrogen from those gaps itself. Okay, that's it. Next of all, it's about
So
vacuum
this
test.
nitrogen will go inside evaporator and
No,
condenser
no.
also?
Yeah, it's
No.
simply meant to be, especially these are preferred for VRF projects. So VRF project consists of lot of pipelines, isn't it? That means the primary piping distance should be comparatively high. So at this time, we don't know where should be the leaks will be there, isn't it? For normal high voltages, it's not required. But I'm trying to say right here itself, for larger piping distances, you must need to do the pressure testing. Otherwise, what will happen? If there is any leaks, the refrigerant will go off from the entire machines and eventually, the entire machine should stop without refrigerant. So that's why we must need to do the pressure testing. For pressure testing, we will be using nitrogen. Once the entire check is uh, once the entire checking is done, we will eventually discharge the nitrogen. And next of all, we will do the vacuum testing. So the concept of vacuum testing is like it's like a dehydration process or evacuation of moisture from the entire pipeline. So normally the vacuum testing is done for around like 24-hour duration. That means it's a long process, guys. For example, if you are doing the vacuum testing for today 10 p.m., then you need to check that for the next day. That's it. Okay, now. So symbolically here, we will be removing the entire moisture content from the pipe system itself. So that is meant to be
How
the
it is removed, sir? Any equipment they are using?
yeah, we having a blower or some kind of pump will be there. Okay,
Okay.
like an
Okay.
air, it's kind of a blower. So these blowers should be set it, and you will be having some kind of meter readings, like a pressure gauge or something. So until the pressure gauge reaches zero, you need to wait. Okay, now.
Okay.
Otherwise, in some other scenarios, I've been seen some kind. The values are mentioned in microns. So I think, yeah. For example, in my site, we started at 8 p.m. for only 12 HP mission, but it's like in 11th floor, but the terrace is like at the 13th, sorry, the 12th floor itself. So we having a large distance of copper piping. Eventually, we waited for like 24 hours, and the reading value should be maintained like 500 microns, but it started with 300 microns. So we need to wait more time until it reaches the 500 microns. Okay, that's it. All right.
13 floor, but each floor will have outdoor like that.
No,
அந்த
it's
மாதிரி
not like
mentioned.
it's for each outdoors. Like, for each outdoor unit, which I'm saying is for VRF projects, you having out ODUs, isn't it? For each ODUs, you will be having separate copper pipelines. Did you get the point? So
Got
for
it.
each,
Understood.
generally this vacuum testing is done in word, not in the intermediate pipe connections here. It should be done right on to the ODU itself. In the ODU side, you have the charging port. On the charging port, you will do this kind of purpose, which means the vacuuming. All right. Next of all, it's about the commissioning. Commissioning is nothing but to check the entire machinery, which means, check all operating parts for free movement, grease bearings, soft pumps, motors, and proper soldering. Run all motors on no load in order to know whether it's working or not. Then check alignment of all moving parts. I told you guys, while placing a machine on floor, especially we need to rise the floor with like a concrete rising, isn't it? And if you have some kind of shock absorbers, you can use that also. Okay, now. Then check the refrigerant level after charging, check vibrations, then check the ducting and piping for leaks. Then properly, once again, you need to properly supply the current levels. Otherwise, the entire boat should be blown off. I told you the VRF boat cost is around like 1 lakh something. Okay, now for a typical VRF, that is entirely communication cables and communication boards will be there for the cut off temperatures. I told you that is now. So if you not provided the proper level of current levels, eventually the entire boat should be blown off. and you need to change the entire boards, which means the circuit board. That's what I'm saying. Then next of all, it's about tab. So tab is a very basic thing in each and every sector, even if it is an HVAC, firefighting, plumbing, whatever else. It is some kind of advisory, or we can say like a maintenance kind of thing. So the first one is testing. So in testing, the process of operating and checking the performance of each equipment, whether it's working properly, is there any faults on the compressor, is the shell and tube is working properly. So it is done by this testing process itself. And next of all, it's about the balancing. So balancing means there are two type of balancings are there. The first one is air balancing and water balancing. Air balancing should be done right inside the ductwork, and the water balancing should be done right inside the secondary pipeline itself. So the concept is very simple. The process of proportioning the correct flow of air or water throughout the system. So how to know this stuff? So initially in the concept of fan selection, I explained you the working. So once the entire duct systems are implemented right on the site, for example, in Maurya project, according to the heat load analysis, we got the CFM value around like 2,980 something around. But we don't have it, and for respective to that CFM, we got the tonnage around like 6.9 ton. But eventually, in our in our client, sorry, the company side, we don't have any kind of machine for 6.9. So eventually, we go off with the next available machine, which is 8.5 ton, isn't it? That is around like 3,400 CFM. Now we can see a difference around like 400 CFM difference is there. So you need to initially control the air comes out from the machine itself. By how? By placing an VCD, like a motorized volume control damper, on the entrance of the duct, which is meant to be the starting point of the duct. Then eventually you can control the air. At the same time, for each room requirements, you can adjust the VCDs. We learned that whenever a branch duct is splitting, especially from a Y-piece connection, you must need to implement a VCDs, especially at the outlets. So once these outlets are setted into a certain angles, with the help of an anemometer, which is used to know the velocity of air. Okay, now, so once you got the velocity according to the Q equal to AV method, okay, according to the Q equal to AV method, for example, how you check in a diffuser, this much 500 CFM is rejecting from the diffuser itself. So how you know exactly the 500 CFM is comes out from those diffuser itself? Very simple. Just place a anemometer right on the outlet side of the diffuser, which means the opening of the diffuser. So, you will be getting a certain value. That means in meter per second value. That is the velocity. Okay, meter per second. So you can simply convert the meter per second value into FPM, which is feet per minute. Once you got the velocity, now Q equal to AV. And I need to find out the Q value, isn't it? So that means area into velocity. That is the only constraint I got. So I got the velocity. For example, the velocity of that air comes out from that specific diffuser around like 500 FPM. Okay, actually, that's not 500 FPM. It should be mentioned in meter per second. So I told you, you need to convert the value from meter per second to FPM. Once you got the value, then next of all, it's about the area constraint. What is the area? It's very simple. Maybe it's according to the diffuser size or the grill size. So by applying the area of that diffuser, for example, 12 cross 12 or even 15 cross 15, which is the inner neck size. According to that value, you will be getting a certain CFM value. Okay, now, is it clear? Hello? Is it clear, guys? So that's how you analyze the uh, CFM which comes out from those each machines itself. I hope it's clear. Is there any doubts? Hello? Is it clear?
நான் டைம் தமிழ்ல சொல்லுங்க சார்.
தமிழ்ல சொல்லணுமா? யா, ஆக்சுவலி இங்க வந்து பாத்தீங்கன்னா நம்மளுடைய ஏர் கண்ட்ரோலிங்னு சொல்றது என்னது? எல்லா வால்யூம் கண்ட்ரோல் டேம்பர்ஸையும் அட்ஜஸ்ட் பண்ணிக்கிட்டு நம்ம ஏர் ஃப்ளோவை ரன் பண்ண விடுவாங்க. ஸோ அட் த டைம் எல்லா டிஃப்யூசர்லயும் நம்ம எக்ஸ்பெக்ட் பண்ற ஏர் ஃப்ளோ வருதான்னு கண்டுபிடிக்கணும். அது எப்படி கண்டுபிடிப்பாங்க? யூ கேன் சிம்பிளி பிளேஸ் அன் அனிமோமீட்டர். அனிமோமீட்டர்ல இது ஒரு காத்தாடி மாதிரி, லைக் சம்திங் லைக் திஸ். Yeah, you can see this now. This is the anemometer. So this is the fan. So according to the fan rotations in per second, this much rotations happening. So you will be getting the velocity. புரியுதா? அந்த velocity வச்சு உங்களுக்கு ஈஸியா Q வேல்யூ எடுத்துடலாம். சொல்றது புரியுதா? ஓகேங்களா? லைக் A into V வச்சு உங்களுக்கு Q வேல்யூ எடுத்துடலாம். ஓகே ஃபைன். நான் சொல்றது புரியுதா உங்களுக்கு?
ஓகே சார்.
ஏரியானா என்ன? அந்த டிஃப்யூசரோட ஏரியாவா இருக்கலாம், இல்ல டக்டோட ஏரியாவா இருக்கலாம். Whatever. That's it. That's it. Then maybe they have other calculation. I'm simply saying it is a thumb rule concept, okay now, rather than if you have some dedicated concepts will be there. The main concept is like this itself, guys. We know that for each diffusers you will be, as per the calculations, a certain velocity. That's how we done, isn't it? 650 fpm on this specific diffuser. So we must need to check whether it's coming or not. That's it. Then, as in the case of water balancing, in water balancing, for each and every AHUs, you having a modulating valve. So you need to set the modulating valves. That means, sorry, not modulating valve, balancing valve. According to the capacity, it will allow a certain amount of water quantity, isn't it? So once you set these entire balancing valve across the entire chiller system, then you run the chiller. So obviously, if there is any pressure imbalance happening, you can take out the reading from those respective pressure gauges deployed around each equipment itself. So that's how you balance your water. Once again, there is some concepts are there, which means in order to find out the leakages in ducts, they will use some kind of safety measure like light testing and smoke testing. Light testing, which means after erection of the entire duct system, they will turn off the entire lights in the floor. After that, it will eventually become fully dark. Once the lights are not turned off, the entire area become dark. And at this time, a high beam light is used to flash around the ductwork. So if there is any leaks happen, the light should scattered from those specific leak holes itself. And the other method is smoke testing. So smoke testing is much more compatible. Why? Because we can easily detect the leaks from the specific ductwork itself. So this is before the installation of insulation. Otherwise, you can't detect that. Okay. So this is the concept. Next of all, adjusting. Adjusting, which means, the process of regulating and setting variables. These are meant to be for, like I told you, according to the pressure sensor feedback, the VFD will work. So that is the concept, which means for 1 bar pressure, this much speed drop will happen. So it should be setted by the certain variables. So it should be already done, guys. You must need to check with those things itself, whether it's done or not. That's it. So this is meant to be the tab system. Okay. And these are the instruments that we will be using in tab to know whether it's working or not. Like for temperature, we will be using thermometer. To check the pressure, you can use manometer or barometer. Then velocity, you can use an anemometer. And flow rates, again, anemometer itself. Heat flow, it is infrared photography. To whether, for example, if any leaks, in order to detect the leaks, you can use this infrared photography. So as if the cold water leaks from that area, the photography should be comparatively different from the normal. That thermal scanner, that's it. Equipment speed, which is the motor speed, you can use tachometer or stroboscope. So tachometer should be plunged over to the rotating shaft, and that's how you take out your reading of the RPM. So this RPM means revolutions per minute. That's how you understand your motor speed itself. And in order to measure the electrical energy parameters, you can use ammeter and voltmeter. Okay. So this is the concept, guys. So is there any doubts on this one? So we completed a lot of topics, guys. Once again, besides that, there are a lot much aspects are there for clean room conditions, especially they having some kind of pack system. So have you ever heard about pack system? Packs means precision air controlling system. So these are meant to be some kind of server rooms. So server rooms are very highly sensitive. Why? Because why I'm saying, while I'm working in Hyderabad, actually, they had a server room, and they started to turn on the entire servers. The entire room become instantly heated up. So in order to cool down the place, we must need to turn on the entire machine. Actually, we provided 5 ton DSA for the entire server. 5 ton into 2. So 2 That means 10 ton capacity for the entire server room. But actually, you know, as an HVAC engineer, I have the authority to take out the remotes and this kind of stuff. So the remote was actually in my shops. That means, the shopkeepers will be there. So that should be maintained in my store. Yeah, in my store. So they had a call with me and to take out the remote, and I just ran into my site, and I just end up with giving this remote to the respective client itself. So the what I'm saying is, so these server rooms are highly sensitive. Okay, now. So for the specific server rooms, we will be providing this pack system. Pack system is nothing but it's like a sensory module itself. So it will continuously check the air quality and the humidity levels right inside the rooms itself. Okay, now, so that is meant to be the pack system. That's it. Okay, I hope this all portions are clear. If you having any doubts, just let me know, guys, because this is the last class. Once again, is there any doubts? ഇതുവരെ എടുത്തതെല്ലാം മനസ്സിലായോ? I hope it's clear. മനസ്സിലായല്ലോ എല്ലാവർക്കും? Okay, எல்லாருக்கும் மனு, ஷாகுல் எல்லாருக்கும் புரியுதா? உங்களுக்கு நான் இதுவரைக்கும் எடுத்தது புரிஞ்சுதா? Why? Because this is our last session of HVAC. Okay தானே? എല്ലാവർക്കും മനസ്സിലായില്ലേ? Okay അല്ലേ?
യെസ് സർ.
Fine, fine.
നോട്ട്സ് ഷെയർ ചെയ്യാൻ പറ്റുമോ?
Sure. അത് നിങ്ങൾ ജസ്റ്റ് ഒന്ന് നാസിർ സാറിന് ഒന്ന് ഹുക്കപ്പ് ചെയ്തിട്ട് കഴിഞ്ഞാൽ ലൈക്ക് he will
ഓക്കെ
guide me whether I need to share or not. Okay. You can
ഓക്കെ.
just
അതുപോലെ
contact.
തന്നെ BOQ ഒന്ന് പഠിപ്പിച്ച അതും കൂടി ഒന്ന് ഷെയർ ചെയ്യായിരുന്നെങ്കിൽ.
ഓൾറെഡി ഷെയർ ചെയ്തിട്ടുണ്ടെന്ന് വിചാരിക്കുന്ന വാട്സപ്പിൽ.
ഞാൻ കണ്ടില്ല, നോക്കിയിട്ട് കണ്ടില്ലായിരുന്നു, അതാ ചോദിച്ചത്.
Once again, no, it doesn't share. One second. Yeah, share ചെയ്തിട്ടില്ല. Yeah, exactly. So I will share those things your system itself. Okay, now. Then once again,
Sir,
guys.
any doubt while going through like in another one?
Sure. You can call me once again, guys. Okay, so this, yeah, I will share those BOQ. Actually, the BOQ concept is same for entire sessions, which means entire sector, like and plumbing, firefighting, whatever you are going. The basic BOQ is very simple. That means the A to Z elements that you will be using across the project itself. That is the concept of BOQ. Okay, yeah, Shafiq, you can contact me anytime. So I hope we can wind up our session. This is the, I told you now initial itself. So whatever, have a great day ahead, guys. So I hope you will be ending up in great heights. So whatever, fine. So you will be catching up with Monday with a different topic on different session. So this is all from me. So if you need any help and assistance, you can contact me right on my WhatsApp or whatever, you can call me on. Okay, so have a great day, guys.